So in the previous video, we looked at power functions, how the graphs look like, and then we looked at power functions with positive exponents, positive integer exponents. So now we're going to consider the power function of the form y equals k over x, or f of x equals k over x. So the difference between this one and the one before we had the y equals k times x, and this was called direct variation. Now when we have k divided by x, we say that y varies indirectly or inversely with the quantity x. So recall from rules of exponents that k divided by x can also be written as k times x to the negative 1 power. So basically when p is negative, and I mean by p k times x to the p, so when this p is negative, we say that the quantities vary indirectly. So let's look at a couple of examples. If y varies inversely as x and y equals 11 when x equals 4, let's find y when x is 10. So as soon as you see that y varies inversely as x, you write down the formula. It's y equals k over x. So y equals k over x. Now, when y is 11, so instead of y, I'm going to put 11 equals k over, when x is 4, I'll put x equals 4. And your goal is to solve for k, the constant of proportionality. So then from here, if I multiply both sides by 4, this cancels. So then I get that k equals 44. So now rewrite the formula you had with what you found that k is. So y is going to be 44 divided by x. So now find y when x is 10. You simply plug in x equals 10. So 44 over 10. So then y is 4.4. So you answered the question. So write down the formula. As soon as you are told that you're working with inversely variation, you write down the formula and then what's given, and then solve for what is not given. So let's look at another example. Resistance offered by a fixed length wire varies inversely. So resistance varies inversely as the square of the diameter of the wire. So let's give these variable names. So resistance, let's call the resistance R, and the square of the diameter of the wire. So the diameter of the wire, the square of it means d squared. So as soon as you read this, write down the formula. Varies inversely, that means that you have R equals K divided by d squared, right? Because the resistance varies inversely with the square of the diameter. Now, if a wire 0.01 inches in diameter, so that means that the diameter is 0.01 inches. So instead of diameter, I'm going to put 0.01 and then squared. K is K. Has a resistance of 0.467. So resistance is 0.467. What is the resistance of a wire of the same length and material but with diameter 0.0372 inches? So basically, first what I need to do always is solve for k. So from here, I see that I have to multiply both sides by 0.01 squared. So then this goes away with this. And then I get that k equals 0.01 squared times 0.467. So let's put that in the calculator. 0.01 squared times 0.467 equals 4.67. This e to the negative 5, it means that this point gets moved to the left 5 places. Okay, so from here, this means that k equals, it was 4.67 So 4.67, and then this moved 1, 2, 3, 4, 5. So basically I'll have 1, 2, 3, 4 zeros in front of that. So 4.67 e to the negative 5 means 0.1234. Okay, so this is my k. So now if I wanted to find the resistance when the diameter is 0.0372 inches, I go back to my formula in here, and instead of k I put this, and instead of d I'll put this and get the result. So r, the result will be r equals, for k I'll put 0.0000467 divided by the diameter 0.0372 squared. So this will be the answer. Okay, so if I put it in the calculator, so this gets divided by 0.0372 squared. Enter. So 0.0337. Sorry. So this is the answer. Also, we could have that a quantity varies with multiple quantities at the same time. And in that case, we say that we're dealing with jointly variation. So you could have a problem that says the following: the weight of a can of a soup is jointly proportional to its height and the square of its diameter. So the weight varies at the same time with the height and the square of the diameter, so with d squared. So we say it varies jointly. So again, you will write it as you write it as y equal instead of y, what varies jointly with height and squared, it's the weight. The weight equals k times the height times the diameter squared. So this is like direct variation jointly. So once you have the formula, plug in what's given and try to solve for what you're asked for. It says a can 4 inches high, so that means that this is the height is 4 with a diameter 3 inches, so the diameter is 3, so I'll put 3 squared, weighs 14.4 ounces, so the weight is 14.4. So k is unknown, so my task is to solve for k and then answer the question for what is the weight of a can that is 5 inches high and with a diameter of 2 inches. So let's solve for k. So 3 squared, that's 9, times 4, that's 36. So if I divide by 36 both sides, I get that k equals 14.4 divided by 36, so 14.4 divided by 36, it's 0.4. Okay, so now that I have k, I go back and plug it in into the formula and rewrite the formula. So the weight equals 0.4 times the height times the diameter squared. So this is what I'm working with now to answer my question. So what is the weight of a can that is 5 inches high? So h becomes 5. So the weight, I'm solving for the weight, is 0.4 times the height, which is 5, times the diameter square, which is 2 squared. So the weight will be 0.4 times 5 times 4, that's 20. So the weight will be, this is like 0.44 times 2, that's 8. So 8 ounces. Okay, so this is how we answer the question. So every time you have a problem that involves either direct variation, inverse variation, or jointly variation, you basically need to know the formula. So for direct, variation, you have y equals k times your input, your x inverse is y equals k divided by the input. But keep in mind that this input can be like square root of x or x squared, diameter squared, or it's different depending on the problem. And then joint variation, y equals k times x times z, if it varies like that. But again, keep in mind that these could be different things. Just like in this case, my x was height and z was diameter squared. It all depends on the problem. All right, so that's it with variation and power functions.